Hey everyone, welcome to the lecture series of Elementary Classical Mechanics, where we embark our journey from basic to advanced physics. This is lecture. We will deal with velocity in 2 and 3 dimension. Then I will take an example on that. So let's get started. If you are familiar with average velocity in one dimension and vector, then this lecture will be relatively easy for you. Otherwise, you can check out my previous video on velocity and vectors. Average velocity is change in position per unit time or rate of change of position. Therefore, it is mathematically represented as delta x change in position upon delta t change in time. For 3 dimension, we replace x by r. Position from the previous video on displacement, you know that delta r is delta x in x direction plus delta y in y direction and delta z in z direction, which will also indicate that the change in position are mutually independent. When we substitute the value of change in position delta r, then we get the average velocity for 3 dimension. And when we take any 2 dimension for change in position with respect to time, then it is 2-dimensional average velocity. Remember to use the vector symbol since velocity and displacement are vector quantity. Do you know for a change in function with a variable, when the denominator approaches 0, then we get the derivative of function with respect to particular variable? If the same thing is applied to the average velocity, then we get the instantaneous velocity. This is the 3-dimensional form of instantaneous velocity. This is how we represent the velocity in 2 dimension. We will deal most of the cases in 2 dimension. Now let us take an example. If a person walks for the displacement 15 meters in x direction and 5 meters in y direction in time 5 seconds, then find the average velocity of that person. We have the vector notion as delta r equals to 15x cap plus 5y cap, and the time delta t is 5 seconds. Now we can substitute the value of position and time. Then we get 15 in x direction plus 5 in y cap whole divided by 5 seconds. Then we get after division that 3 meter per second in x direction and 1 meter per second in y direction. This is average velocity. If you are finding difficulty in understanding this concept, I am sure that you should watch my video on vectors and scalars. Hey, you made through the video. My next lesson will be on instantaneous acceleration in 2 and 3 dimension. If you liked the video, please click the like button. For more of my lectures, you can subscribe. Your gracious subscribe will encourage me to work harder and better. Till then, goodbye.